Okay. We're talking about probability of compound events today. Now, I like this lesson. I used to not like it when I was your age. I didn't quite understand it at all. Actually, I don't even know that I learned it until I actually went to college. So, things have changed over the years. Here's the deal. We're going to be talking about occurrences, things that are happening. Some of those things will be independent events, and some of them will be dependent events. The difference is pretty straightforward. Suppose I have an apple, an orange, and a banana. Okay? I have three different types of fruit. I'm going to eat the banana. And now I'm going to let you choose a piece of fruit. Did you get to choose from the same fruits that I got to choose from? I took away one of your options, didn't I? So what you get to choose depended on what I did first. So what I did affected you, didn't it? So that would be a dependent event. The second choice depends on what happened in the first choice. They're connected. Whereas if I had three apples and I ate an apple and I said, "Oh, would you like to choose a piece of fruit?" You wouldn't get any, there would be no issues, right? Because I had an apple and you get an apple as well. So everything would be the same. That would be independent. My eating one apple didn't affect you eating an apple. Okay? So that's kind of what we're talking about today. Things that are affected or not affected by the first choice in the situation. Now, every time you're given an opportunity to do a probability, you make the assumption that the person got what they were looking for, which doesn't make sense to you yet, but it will. So if we look at these notes, and one of the most important things is to establish how many total items you're talking about to begin with, because that will be your denominator. You're going to build lots of fractions today. The denominator is always going to be the total amount of things that were talked about. And so in this first example, there's a bag that contains 12 marbles. All right? 3 are green, 2 are blue, 6 are yellow, and 1 is red. Jamma is going to choose a marble, and she records the color. Then she puts it back into the bag. Then she chooses another marble. Okay, so let's think about this. Would these two choices, are they dependent or independent? She picks the marble out of the bag, but she puts it back. So they're independent because the second choice had the same chances as the first choice, right? Because she put it back, we start over again at the beginning with the same number of items and everything's the same. So they're independent. The first choice had nothing to do with the second choice. So now we're going to kind of establish what the answers are. So we assume, like I said, we're going to assume that she's going to get a green one when she picks it. That's what probability is. So it's written like this: P parentheses whatever you're looking for. Okay? So we're looking for the probability on her first pick to be a green marble. How many total greens were there? 3 out of a total of? So that's how we got this fraction. This was the number of green ones she could choose from, and this was the total number of marbles in the bag. So a 3 out of 12. Correct. And you can simplify it if you want to, but it's not necessary because we're going to use our calculator and we're going to do multiplying and dividing, so it's not going to matter that much. So 3 out of 12 for her first choice. She puts it back into the bag like they said, and now she's going to reach back in, and what's the probability of her getting a green one again? It didn't change, did it? So it's still 3, still 12. I have the two probabilities, and to put them together, the word "and" in this lesson means to multiply. Okay? So the probability of A and B occurring is the same as the probability of the A for A times the probability of the B event. So the probability of the green times the probability of the green, 3 over 12 times 3 over 12 is 9 over 144. Work your fraction from the top to the bottom. 9 divided by 144 gives you approximately a 6% chance of that actually happening. Yes, sir.
So instead of writing 3 over 12, can I write 3 over 12
No, because it isn't squared. It's no, it is squared, but that's not what you're going to want to do because I don't want you to get confused later on when we have more things that aren't exactly the same. Don't confuse yourself, okay? It's just basic multiplication. So you okay with that idea? Pretty straightforward, I think. All right. So that was an independent situation. Now let's look one that's dependent, and this is about the deck of cards. So I wanted to kind of go with that. All right, so there are going to be 4 cards out of the deck that are drawn randomly, okay? Find each probability if the cards are drawn in the order indicated. Okay, I'm looking for the probability of choosing a number 4, then a probability of picking a king, then the probability of getting a queen. It needs to be in that order. So we're going to take the probability of each one of those individual events and then put them all together in the end, all right? Now, oops. Okay. Now, the key word here was it's not being replaced. So once I've picked something, I'm not putting it back. So my denominator is going to be changing every single time, isn't it? Because if I pick something and I don't put it back, I have fewer things to choose from on the next round. So it's very important to pay attention to that. So let's talk about the number 4. What is the probability of me getting a 4 out of a deck of cards? Well, how many total are there in a deck of cards? 52. And how many of them would be the number 4? 4. Each suit contains the number 4. There's a 4 of hearts, 4 of clubs, 4 of diamonds, 4 of spades. So there's 4 number 4s in a deck of cards. Okay. What is now the probability of choosing a king? 4, because there's a king of diamonds, clubs, hearts, and spades. So it's 4 out of 51 this time, though, right? Because when I got this number 4, I took a 4 out. I now have 51 cards left to choose from. I'm choosing a king. I'm taking the king out. So now I'm down to 50 cards in my deck to choose from, and I want it to be a queen. So now I have 4 out of 50 cards that could be a queen. Does that make sense? All right. Here's where you're assuming you really did get what they are hoping you get, okay? Now we're going to multiply those 3 values together and then turn it into a percent. So the probability of choosing a 4, a king, and a queen in that order would be 1 out of 13 when you simplify the fraction, which you didn't have to do, 4 out of 51, and 2 out of 25. Once again, they simplified the fraction, but you don't have to. You're going to multiply straight across. The numerators get multiplied together, the denominators get multiplied together, and you get 8 over 16,575. Turn that into a percent for me. Tell me what you get as a decimal, and then we'll change it to a percent. All right. So if I were to change that to a percent, I have to scoot 2 places, 0.04 or even 0.05. There's a 0 in there, okay? Percent, which is very, very, very little as far as percentages go. Now, was this independent or dependent? It depended, because what happened on the first made a difference or a change in what I picked on the second and the third choice, right? So that's it, they depended on it. Let's see if we can do this triad at the very bottom down here, sort of. What's the probability of choosing a spade, a club, and a heart, and not a heart? Not a heart. Okay, and it has to go in this order from a deck of 52. So how many spades are there in a deck? 13 total. How many clubs? 13. Hearts and diamonds. Okay, I just put that there to help you get a visual. All right, so I need the probability of choosing a spade. Okay, so what would my probability be of choosing a spade out of this deck of cards? Yeah, 13 out of the total deck of 52. So we would have 13 out of 52. That's my spade, so I took care of that one. Now I'm going to choose a club. How many clubs are there? Okay, out of 52. Well, we're not removing them. We're not removing them. So, and then I have 13 now out of 51. Right? Oh, wait a minute. Yeah, we are removing them. I'm sorry. Sorry. Yeah, we are removing them. I apologize. And now, not a heart. How many would be not hearts right now? So we have this, this, and this, which would be 39, but we took a heart, we took a spade and we took a club. So I need to minus 2 to get 37, right? Because I took one from here and I took one from here. So instead of having a total of 39, I actually have 37 to choose from now, out of 50. So now I have 37 cards out of the remaining 50 because I took 2 out of the deck. And those 2 were actually the ones that I chose here. So now we're going to multiply all of that together, and on the back, you can see if you're right. Okay. So it kind of wasn't a try it, but I thought it would be a good place to do a try it. So there we go. It worked out well. Do you get it? Okay, if you're not getting it, you better be speaking up and not sitting there quiet. So talk to me. What part did I lose you at? Talk to me. You have to give me information or I cannot help you. You have to show me where you stopped understanding. Yes, sir. Okay, I subtracted 1 because my first draw was a spade, right? I hadn't removed any cards from the deck whatsoever. But if I remove 1 card, I now have 51 to choose from. Are we good with that? And so then on the next thing, I'm choosing to remove 1 again. That's why the numbers keep getting smaller, because I keep picking cards, okay? All right. Anybody else have a question? There's no bad questions. It's when you sit there and don't talk to me, it's a bad thing, because you get further and further behind. Are we okay? All right. So those were examples of dependent and independent. All right. Now we're going to get down to things that are called exclusive, mutually exclusive, and not mutually exclusive. What does the word exclusive mean? Exclusive. Rare. Okay. What else might it mean? Exclusive. It's an exclusive club. Yeah. Members only, right? So only certain things. It doesn't include more than one type of group. It's slightly independent in a way. It's unique to itself. Okay. Now, in this particular assignment, mutually exclusive means they don't occur at the same time. Okay. So we have this person. They have 25 CDs. So 25 is our total. Out of these CDs, they have 8 that are rock, 8 that are jazz, 2 are rap, and 7 are classical. This person's going to choose 1 CD at a time, and I want you to find the probability. Well, the first probability that we want to find is the probability of this person picking a jazz or a rap. Do you notice something different here? The others were the word and we multiplied. This is an or. We'll actually add. I know. I wish it was the other way around. It'd be easier to remember. So or means to add. So maybe we want to put a little note up there. Or means to add. All right. So we're going to find the probability of the jazz by itself and the probability of the rap by itself. Then we'll add those 2 probabilities together. This one's not multiplying. Okay. So the probability of jazz, that's 8 CDs out of 25. The probability of rap was 2 CDs out of 25. And so you can see right here is where they kind of set it up. It's the probability of the jazz added to the probability of the rap. So 8 over 25 plus 2 over 25, we're talking 10 over 25. Divided by 5, it simplifies, and you get your 2 out of 5, which is the same as 40%. So there's a probability of him choosing a jazz CD or a rap CD is 40%. That one fairly straightforward? Okay. See if you can, on the try it, find the probability of choosing a rock or a classical CD. You set these up. So it's important to know what the total was. And then go back and find the types you're interested in. All right. So how many rock CDs were there? 8. So I have 8 out of 25 that were rock. Then there were 7 out of 25 that were classical. We're going to add those two things together to get 15 out of 25. There's no rap here. Yeah, there's no rap on this part. Okay. Uh-huh. And so when you simplify this by dividing by 5, or you can just put it in your calculator, it makes no difference to me. You would get a 3 out of 5, which is the same as 60%. No. If you do what? Oh, you multiply by 4? Yeah. Yeah, that's fine. Okay. Now, does it make sense, though, that these two became 60% of the total? Because weren't these two up here 40% of the total? So the first two types came to 40%. The next two types that he had in the bag, because he had a total of 4 different types, came to 60%, and the 40 plus the 60 make 100% of the CDs that he owned. Okay. How many of you are kind of okay up to this point? Okay. You seem to be doing a little bit better than my other hour. So let's see how it goes. This last one is where you kind of have to pay attention because things get double counted. All right? Not unlike, is anybody in here in band? Raise your hand. All right, you guys who are in band, are you also in something else? Anybody? What are you in?
Cross.
Okay, so you would be my double dipper, all right? Because you have your foot in the band ring and you have your foot in the sports ring, the lacrosse ring, right? So you would be someone who, if I counted, I need the probability of band members, you would raise your hand. I would count you in that group, wouldn't I? Then if I said, okay, all of my sports players, you would raise your hand again, and I would count you in that group. Well, does it make sense to you if I'm counting you twice? My probability is not accurate, is it? Well, but in the end, let's suppose I was supposed to find the probability of my band people and my sport people. But he would be counted twice, so that's not accurate. So I would have to remove him from one of those groups to make an accurate reading, all right? You'll see it here in a second, all right? But that's kind of what's happening. When they're double dipping, you have to remove them from the total so that you don't accidentally count them 2 times. Okay? So, but then I'm not counting him at all. I have to count him, though. I have to count him. So here it is. So right here, pay attention to this, and this will maybe make it more clear to you. Okay, these are not mutually exclusive, meaning this could happen at the same time, such as him being in band and lacrosse at the same time. Okay? So there's 26 students in Mr. Collins' English class. So the total students is 26. 12 are seniors and 14 are juniors. 8 of those seniors are boys. 6 of them are juniors, are boys. What's the probability that a randomly selected student is a boy or a senior? Because can you see how he's kind of in both categories? A boy and a senior would be the same as a band member or lacrosse. That's where the double counting is. So what we need to do is go back. Since we're looking for a boy or a senior, we're going to find the probability of each of those two as they are. Okay? So how many boys were there according to this? Well, I had 8 boys and 6 boys. So I have a total of 14 out of 26 students were boys. Then, how many were actually seniors? Well, 12 are seniors. So I had 12 out of 26 as being seniors. So far, so good? All right. Now, we have to remove anybody who was in the category as a boy and a senior. So it says here, 8 of the seniors are boys. So there's where 8 out of all of them, 8 out of the total. Boys and seniors. There were 8 out of the total 26. This category was boys. This category was seniors. These guys were already counted into these two groups. I need to remove anybody that was counted in both groups. And they tell me right here that 8 are seniors and boys. So 8 are seniors and boys. So I need to remove those 8 from the class of 26 because I've double counted them. So I'm going to take this number and then subtract this number. So I'm going to take the probability of my boys, which was 14 out of 26, plus the probability of my seniors, which was 12 out of 26, and subtract the ones that got counted twice, which was 8 out of 26. So when you finish with this, you're going to get 16 out of 26. Is it 18 out of 26? Or is it 18? 18 out of 26, sorry. And when you plug that into your calculator, that's 9 over 13, which turns into approximately, what is it, 69%? Okay. Okay, so you have about a 69% of choosing a boy or a senior. Does that make sense? Just be careful on the double dipping ones. And if you're not sure what they are, I'll be happy to help you. Okay? Does anybody like this at all? A little bit? A little bit, some of you? Okay. Yeah. The notes, on the front of the notes are your assignment. Okay? And so maybe here you also want to write that and means to multiply. And always find your totals first. Okay? The assignments at the top of the page, 797, 1 through 16, and number 31. 31 is a Venn diagram. So if you struggle with reading that, let me know and I'll help you, okay? It's in the book. So you can come see me if you need some help. I'll put the card thing back up there for you, so you have an idea of how many cards are in a deck, etc., etc. Okay? Yes, sir. Uh-huh.